Okay, Chemistry 3101. We're going to wrap up IR almost, or not quite. There's one more section to look at, but I wanted to try a couple of problems here. This is question 14.9, comes straight out of your textbook, and it asks us for each of the following infrared spectra, so there's A through F here, 6 different spectra. Identify whether the structure is consistent with an alcohol. So identify whether we're dealing with an alcohol, a carboxylic acid, which is this, okay, or neither. Well, if we go over to our table of infrared absorption frequencies, we saw that for an alcohol, what are we going to see? We're going to see an oxygen-hydrogen stretch, okay, that's going to be between 3650 and 3200 reciprocal centimeters. Okay, something else that we could look for would be the carbon-oxygen stretch. So the carbon-oxygen stretch is around 1250 to 1000 reciprocal centimeters for our alcohol. Then for our carboxylic acid, there's a few more things that we could look for the carboxylic acid, but we're going to look for a really broad oxygen-hydrogen stretch. It can range all the way from 3,300 to 2,400 reciprocal centimeters. We saw that the carbonyl is going to be around 1710 reciprocal centimeters. And then lastly, the carbon-oxygen stretch is going to be somewhere between 1320 and 1210. So 1320 and 1210 reciprocal centimeters. So we're going to use all of this information right here to help us determine whether we're dealing with an alcohol or a carboxylic acid in these spectra. All right. Or what's the last one is neither. Okay. I'm going to ask my students, my students are good thinkers. What about A? Could anybody surmise what we have in A? Would this be an alcohol, carboxylic acid, or neither of those? If I take my ruler, and I draw a line around 3,000 reciprocal centimeters, is right around here. Yeah, my students are saying alcohol. Absolutely, right? Because for an alcohol, we know that the absorption for the oxygen-hydrogen stretch is going to be between 3,200 and 3,650. So if we zoom in here, this is 3,000, 31, 32 would be here, and 36-ish is around here. So that kind of falls in this range. And so this is the oxygen-hydrogen stretch, okay, of our alcohol. We could also look for the carbon-oxygen stretch of our alcohol, which is around 1,000, between 1,000 and 1,250. So we have 1,000 here, 11, 12, 1250. So it's probably this thing here. This is probably our our carbon-oxygen stretch. Carbon-oxygen stretch for alcohol. Okay, like that. What about C? Let's move over to C. Does anybody have any thoughts about C? What does C look like? Yeah, absolutely. Absolutely. My students are all nailing it. They're saying, Mr. Dion, this looks like definitely a carboxylic acid. Look, if you really want to get down with it here, you can get your ruler out, say around 2,400, which is about here. Okay. And then between 2,400 and 3,300. So, oops, where's my ruler? 3,300 is around, come on, ruler. There we go. 3,300 is around here. Okay, like that. So somewhere in that range, but you see that you've got, a huge oxygen hydrogen stretch that just goes on forever, So this tells you that this is a carboxylic acid. Okay, what else do you see for a carboxylic acid in here? Is there anything else that looks interesting to you? Yeah, exactly. Both of my students are correct. Mackenzie and Bruna, you're both bang on the money, right? They're saying somewhere around here. Yeah, it looks to me like that's around 1710. So this is the carbonyl stretch. Okay, carbonyl stretch. And the last one that we could look for the carboxylic acid would be the carbon oxygen stretch, which would be around 13. So it might be one of these ones here. I'm not sure which one, but you could circle them both and say carbon oxygen stretch like that. All right. What about B? Does anybody have a thought about B? Yeah, I agree with you both. Mackenzie, Allison, Benjamin. Yep, yep. You're all on the right page to me. I don't see anything here. How would you know that right away? I mean, you can do it the hard way or the easy way. I mean, you could start by putting the ruler over here at 3,000 and drawing a line, and saying, okay, well, I don't really have anything above 3,000, so there's no oxygen hydrogen stretch. And so the answer is neither for this one. What about D? For D, I'd say it's neither again. Yep, there's nothing here. No oxygen hydrogen stretch. Yes, so here, oops. Here it's neither as well. Let's try a couple more. What about E? Yeah, I think it looks like an alcohol, Jonathan. I agree. Yeah. So between 3,200, so we'll draw a line around 3,200, which is around here, and then 3,650, which is around here. Okay. Either way, we see that we have, and it's close, but we have a broad absorption here. So we'll put, oxygen, hydrogen stretch. There's no carbonyl, right? So no carbonyl. And then we have this, which might be the carbon oxygen stretch. And so this would be an alcohol. Okay, and the last one, does anybody have a thought about the last one? Yeah, thanks. Everybody's correct, right? They have a big old oxygen hydrogen stretch that ranges all the way from here to like here. So this is an OH. I'll just delete this. Oxygen hydrogen stretch. I have I'll just draw a line like this. Carbonyl stretch. Okay, and this is probably my carbon oxygen stretch. And this is a carboxylic acid for sure. Carboxylic acid, just like that, my friends. There you go. Let's move on from there. For each of the following IR spectra, I'm just thinking here. For each of the following IR spectra, determine whether it is consistent with the structure of a ketone, alcohol, carboxylic acid, primary amine, or secondary amine. So here they get a little bit trickier. You get significantly trickier.